when you're finding reference angles, and I put this in several different parts of instructions, if your angle is given in degrees, you need to make sure your answer is in degrees, or if it's given in radians, you need to write your answer in radians. And that's the same for coterminal angles as well. So, but for reference angles, if you draw an angle and you find where it ends, so let's say we have an angle that ends here, your reference angle is between your terminal side, so wherever your angle ends, and the nearest x-axis. So if it's over here, if it ends anywhere on the left, so if it's on the left up here, it goes to the left x-axis. So this angle or this angle if it ends here. And if it ends on the right, here, wherever on either of these quadrants, it goes to the right x-axis, always to the x-axis, never to the y. Even if it's like really close to the y-axis, a lot of people are tempted to go to the y-axis, but you can't. You have to go to the x-axis. So it's always acute, so less than 90, and it's always positive. So let's look at one of these guys. So let's look at 130 degrees. So if I sketch 130 degrees, and again, you don't have to sketch it if you know how to find this without, just show your work, that's totally fine. 130 I know ends over here in quadrant 2. I'm just sketching it, I don't have to draw it to scale. And I know the closest x-axis is going to be here at 180 degrees. So all I have to do is I have to find the difference between 180 and 130, and that's the difference, that's the distance between here and here. And remember, it's always positive, so just do the bigger one minus the smaller, and there's your reference angle right there. So let's see, so 200 ends almost kind of in the same place, but I mean on the same side anyway. But 200 is below the x-axis, it's down here, but still the closest one is 180. So this time we find the difference between 200 and 180. 200 is the bigger, so I'll just use that first. You just minus them, find the distance, and 20 degrees is that size of that angle right there. When we're looking at radians, 5 pi over 6, or let's do a negative one. So let's look at negative 5 pi fourths. So if I sketch this, remember, this is 0, and if I go halfway around going this way, because negative, you have to go down from your starting side, your initial side. So going this way, you break it up into fourths. So here's like a half. Let's break that up in half again. Okay, so that's 1/4, 2/4, 3/4, 4/4, 5/4. So you have to keep going. So negative 5/4 is going to be up here. So if I go all the way around here. But remember, we are looking specifically in this case for the reference angle. So that's how we graph it. But remember, the reference angle is only the distance. It's only the angle between the terminal side and the x-axis. So it's this angle right here. So you just work with like the fourths. I mean, we broke this up into fourths, so my answer is going to be in the same denominator. It's going to be a fraction, but it is going to be positive. And remember, we broke this up into chunks, so that like this was a fourth, this was a fourth, this was a fourth, this was a fourth, and this was a fourth. So we had 5/4 all the way around. So my reference angle is just one of those. So 1/4 of pi. And it's positive, so you just leave it as positive even though my original angle is negative. So there we go. There's my reference angle. Okay.